Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is CH3C is equal to O, CH2C, CH3, 2-CHO, which is 2,2-dimethyl 4-oxopentenyl, a ketoaldehyde. It has a ketone, CH3CO, at one end and an aldehyde, CHO, at the other end, separated by a CH2 and a quaternary carbon bearing two methyl groups. Moving on to the next step. KOH H2O is a base-catalyzed intramolecular aldol condensation condition. Moving on to the next step. Under basic conditions, the alpha carbon of the ketone, the CH2 between the ketone and the quaternary carbon, is deprotonated to form an enolate. This enolate carbon then attacks the aldehyde carbonyl intramolecularly. The aldehyde carbon is 3 carbons away from the alpha carbon of the ketone, counting alpha C, quaternary C, aldehyde C, forming a 5-membered ring upon cyclization. The ring includes enolate carbon, quaternary carbon, aldehyde carbon, plus the new C to C bond, and the oxygen becomes O. And for the final step, the intramolecular attack of the enolate on the aldehyde gives a beta-hydroxy ketone in a 5-membered ring. The ring formed contains C, ketone, CH, C, CH3, 2CH, O, closing back, giving a cyclopentane ring with a ketone and a hydroxyl group. Under the basic aqueous conditions with heat, the beta-hydroxy ketone undergoes dehydration, elimination of water, to give an alpha-beta-unsaturated ketone, enone. The O on the former aldehyde carbon and the H on the adjacent carbon, the alpha carbon to ketone, are eliminated to form a double bond. The product is a cyclopentane ring. The ring is 5-membered with the carbonyl, ketone, at C1 a double bond between C4 and C5, alpha, beta to the carbonyl through the ring, and gem-dimethyl substituents at C3. This corresponds to 4,4-dimethylcyclopent 2N1-1 or described as 3,3-dimethylcyclopent 4N1-1 depending on numbering. Looking at option B, it shows a 5-membered ring with the ketone at the top, a double bond on the lower left portion, and gem-dimethyl at the bottom carbon. This matches the product of the intramolecular aldol condensation where the gem-dimethyl quaternary carbon is retained in the ring and the double bond forms between the former alpha carbon of ketone and the former aldehyde carbon. Option A has gem-dimethyl adjacent to the carbonyl, C2 position, which would require the quaternary carbon to be alpha to the ketone, not consistent with the connectivity. Option C is a 6-membered ring product, but the chain length only supports a 5-membered ring cyclization. Option D is a 5-membered ring with only one methyl substituent, losing the gem-dimethyl pattern of the starting material. Therefore, the correct answer is B. Therefore, the correct answer is option B.